To test if the rooms generate correctly and do not generate inside each other, I have generated a new map and printed the X, Y, width and height of each room that the algorithm attempts to generate. That can be seen down here. So first, a room was attempted to be generated at the coordinates x4, y7 with a width of 4 and a height of 4. This room was generated since there were no other rooms that intersect with it, so it could generate correctly. Next, it attempted to generate a room at x4, y2 that was 4 by 4. That room was not generated as it would have intersected with the room at x4, y7. Then it attempted to generate the same room, a room with the same specifications, x4, y2, a width of 4 and a height of 4. This room was also not generated as it also intersected with the room at x4 and y7. Finally, it attempted to generate a room at x11, y13 that was 4 by 4, and that room was generated as it did not intersect with any other rooms. It didn't intersect with the room at x4 and y7, so it could be generated, which shows that rooms that intersect with each other are not generated and therefore no changes are required. So as we can see here, the positive X and positive Y tunnel has generated from this room to this room, and it has generated correctly as it has gone across and down neatly into the very center of the room, so no further action is required. So as we can see here, the positive X and negative Y tunnel has generated correctly from this room to this room. So it has gone across and up to the very dead center of the room. No further action is required. As we can see here, the negative X, positive Y tunnel has generated correctly from this room that I'm in to this room, and it has gone left and then down to the dead center of this room. No further action is required. So as we can see here, the negative X, negative Y tunnel has generated correctly from this room to this room. It's gone left and up to the dead center of this room. No further action is required. To test that enemies do not spawn in the same room as the player, I have temporarily disabled the dice roll that determines if enemies will spawn, and instead I've hard-coded it so that every time an enemy will spawn up to the specified max enemy number, which currently is set to 2. So as we can see here, 2 enemies have spawned in this room because enemy spawns are guaranteed. However, none have spawned in the same room that the player spawned in, which is this room. Therefore, no further action is required. To test if loot, chests and enemy sprites will spawn on occupied tiles, I've removed the dice roll that determines if they will spawn, and I've hard-coded it so that every time they are guaranteed to spawn. This means they're guaranteed to spawn for every attempt. I've done that for both loot and enemy sprites. I've also set the specified number of loot chests and enemy sprites to 100. This means it will attempt to spawn an enemy sprite and a loot sprite 100 times. So in theory, if every room has 16 tiles After each tile has an entity spawned on it, such as a loot chest or an enemy sprite, no more loot chests or enemy sprites will be spawned on any tiles, as all will be occupied, and this will be despite the algorithm attempting to spawn a loot chest and an enemy sprite up to 100 times. This will prove that enemy and chest sprites cannot spawn on occupied tiles. So as we can see here, there are only 15 loot chests that are in this room, and by opening them I can prove that there are no other loot chests in the same place. I've also printed the number of loot chests and enemy sprites to the screen. As we can see, there are only 15 loot chests and 15 enemy sprites that have spawned in, and we can see that here. This means that despite the algorithm attempting to spawn loot chests and enemy sprites 100 times, only 15 have been spawned, since that's how many could be spawned based on the free space available, which proves that enemy and chest sprites will not spawn on occupied tiles and no further action is required. To prove that floor tiles can be walked through by a being, I have spawned onto a new map as the player, which is a child of the being class. And as we can see, I can freely move through the grey floor tiles unrestricted. Therefore, no further changes are required. In order to test that wall and occupied tiles cannot be walked through by being, I have spawned into a new map as the player and will now attempt to walk through wall tiles and occupied tiles. As we can see, I cannot walk through wall tiles in any direction. I also cannot walk through occupied tiles. And as you can see, once the tile is no longer occupied by the chest, I can now walk through it. Cannot walk through these tiles either because they're occupied by the enemy, and I also cannot walk through this tile as occupied by the exit. Therefore, this works correctly and no further action is required. In order to test that when a being's health reaches 0, they die, I've spawned into a new map as the player, and I will now let this enemy down here attack me until my health reaches 0. You can see the health represented by the number of hearts we have here. So we have 5 hearts here, that means we're on 5 health right now. So let's let our health reach 0 and see if we die. Our health is now at 0. I'm trying to move, but it will not let me. It goes to the game over screen. So this therefore proves that when a being's health reaches 0, they die, and no further action is required. In order to test if pressing W lets the player move up, spawn into a new map, and now I'll attempt to move upwards. As we can see, the keybind works correctly and no further action is required. In order to test if pressing I lets the player move left, I have spawned into a new map as the player, and now I'll attempt to press the A key. As you can see, the player moves left every time I press the A key, therefore no further action is required. In order to test if pressing S lets the player move down a key, I've spawned into a new map, and now I'll attempt to press S. As you can see, every time I press S, the character moves down a tile, therefore no further action is required. In order to test if pressing D allows the player to move right a tile, I have spawned into a new map as the player, and now I'll attempt to press D. As you can see, each time I press D, the player moves right a tile, therefore this works correctly and no further action is required. In order to test that pressing spacebar with the tile directly in front of the player having its self-dot object attribute set to none allows the player to perform their attack animation. I have spawned into a new map and will now attempt to press space bar facing each direction. As we can see, it works when the player is facing forward, works when the player is facing left, works when the player is facing backwards, and works when the player is facing right. Therefore, no further action is required. In order to test that when the user presses the spacebar with the object attribute of the tile that the player sprite is facing set to a chest, will spawn a loot sprite in its place and remove the chest. I've spawned into a new map and I'm going to attempt to press space while facing these loot chests. As we can see, the loot chest was removed and a loot sprite was spawned in its place. This is true for all the other chests on this map, therefore no further action is required. In order to prove that when a enemy is on the tile in front of the player and the spacebar is pressed, the enemy takes damage based on the player's damage stat. I've made my program print the enemy's health to the screen after they've been attacked by the player. So now you can see we've spawned into a level. Here's an enemy. His health is now 0 after being attacked by the player. Same here. This therefore proves that the enemy can be successfully attacked by the player if they're on the tile in front after pressing spacebar and no further action is required. In order to prove that pressing F with a health potion equipped increases player's health, I have currently got a health potion equipped in my inventory and I will now press the F key, and if the player's health increases then the number of hearts displayed here should increase. And as we can see here, it has increased, so this works correctly and no further action is required. In order to prove that pressing F with a damage potion equipped increases player's damage, I have made my program print the player's damage to the screen before and after the potion has had its effect on the player, so we'll now test this. So as we can see here, I've got a blue potion equipped, or a damage potion. Now I'll press the F key. As we can see here, my damage was previously 1, is increased to 3. Therefore this works intended and no further testing or no further action is required. In order to test if pressing R will drop the currently selected item, I've spawned into a new map and picked up a blue potion. I will now press R. As you can see, the item is dropped to the floor. The tile that it was dropped on was given new properties correctly, like occupied being set to true. I can pick it up again, and those same properties are now removed from the tile, and I can drop it again. So as you can see, this works intended and no further action is required. In order to test that pressing the specified number key changes the player's current inventory slot to the appropriate inventory slot, I have spawned into a new map and I've got a full inventory of items. I've got an item in every single slot. I'm currently on slot 1, sword T3, and as I change to each different slot, it should display a new name for the item that is currently equipped, which should prove that the number keys work as intended. So I press number 2, blue potion, that's correct. Number 3, green potion, that's correct. Number 4, red potion, that's correct. Number 5, sword T1, that's correct. Press number 1 again, back to sword T3. This shows this works as intended and no further action is required. In order to test whether the player gains and loses damage appropriately when interacting with a weapon, I've spawned into a new map, as you can see here, and I will now pick up the weapon that is in front of the player, and the damage number that it has will be printed to the screen. So as you can see, I have picked up the weapon, and now my damage number is 5, as can be seen here. Now if I swap to a different inventory slot by pressing 2, my damage is lowered to 1 as appropriate. Now if I change back to the weapon slot, my damage once again goes to 5, and this therefore proves that this works correctly and no further action is required. In order to test that pressing space while facing the exit point allows us to progress to the next level, I've spawned into a new map and I will now attempt to progress to the next level by pressing space while facing the exit point. So as you can see, the player is facing the ladder or the exit point, and I'll now press space, and I've successfully transitioned to the next level. You can see in the top left the level numbers updated, and I can do it again on this ladder down here, and the same's happened again. Progress to level 3, do it again, level 4. Therefore, this works intended and no further action is required. In order to test if pressing space while facing an item allows you to pick up the item, I've spawned into a new map, and I will now attempt to pick up some of the surrounding items here. So I'm going to attempt to pick up this red potion that I'm facing right now. As you can see, we picked it up. So we are currently on inventory slot number 2, so in theory it should not let me pick up any more items for this slot, so I'll attempt to pick up an item, and as intended the system did not allow me to pick up the item. Swap to a new inventory slot, press space, and as you can see I've picked up this new item. Swap to a new one, press space, and I've been allowed to pick up this item as well. This shows that this system works as intended and no further action is required. In order to test that moving up a tile moves the camera upwards, I've spawned into a new map as the player, and I will now move upwards. As we can see, every time that the player moves upwards, the camera moves up a tile with them, therefore this works correctly and no further action is required. In order to test that moving left makes the camera move left a tile, I've spawned into a new map as a player and I will now attempt to move left. As we can see, every time that I move left, the camera also moves left, therefore no further action is required. In order to test that moving down makes the camera move down a tile, I've spawned into a new map as a player and I will now attempt to move down. As you can see, every time that I move down a tile, the camera also moves down the tile. Therefore, it works correctly and no further action is required. In order to test that moving right makes the camera move right a tile, I have spawned into a new map and will now attempt to move right. As you can see, every time that I move right, the camera also moves right, therefore this works correctly and no further action is required. In order to prove that enemies can find the shortest path to reach the player, I have created a function that displays an X on any of the tiles, on the tiles that represent the shortest path to the player that the enemy has calculated. As you can see here, the path starts here, moves up here, along here, and correctly to the side of the player from where the enemy can attack. If I move, the path adapts. If I move left, path adapts again to move around all the objects. Path keeps adapting. The path no longer exists as there's no way for the enemy to reach me here because both sides are blocked. However, if I move again, the path can be recreated, so it's recalculated towards the player. You can see that it works correctly to find the shortest path to the player. Therefore, no further action is required. In order to prove that enemies only attack the player when in the specified attack distance, I will show the enemy path towards the player, and once they're within the specified attack distance, they should attack the player. The specified attack distance is 8 currently, so that means that when the enemy only has to make 7 moves to get to the player, they will start moving towards the player to attack them. This is 7 instead of 8 because of how ranges work in Python. As you can see here, the enemy has to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tiles to get to the player. Do note that the amount of tiles to get to the player does also include the tile they start on. So now it includes 1, 2, 3, 4, 5, 6, 7, 8, 9. So in theory, if I move to this tile here, then the enemy should start moving towards me to attack me. And as you can see, now that I'm within the specified attack distance, the enemy starts moving towards me to attack me. Therefore, this works as intended, and no further action is required. In order to prove that enemies only attack the player when on the tile next to them, I've spawned into a new map, and now I will let the enemy walk towards me and see if they start attacking me, which should also drain my health. So this enemy is walking towards me, and he has only started attacking me now that I'm on the tile next to him, and that drains my health. I have now died. Therefore, this proves it works as intended, and no further action is required. In order to prove that my system works as a whole, I've loaded into a new level, I've started a new game, and I'm going to attempt to go through until level 15 to prove that the gameplay systems work and my system works overall. And that is the end of the game right there. This proves that my system works as a whole. So in order to prove that the levels are randomly generated and that they are not hard-coded, I'm going to do another run through until level 15, mainly just showing off the levels this time instead of showing more of the gameplay to prove that the levels are randomly generated. So as you can see, the levels are randomly generated and this works correctly, therefore no further action is required.